into the product cycle and try to improve Kuma as we go. So, Kaylin, are we good on the recording side of things right now?
Yep, got everything
Okay,
set.
awesome.
Let me get the slides up here. So welcome everyone to September's community call. We are focusing this call around Kuma, which is our latest open source project. Marco Palladino, who is our CTO, is going to be presenting today. And then I just wanted to go through a few announcements before we get started. So today's really exciting. We have the 0.6 release of our Kubernetes ingress controller coming out. So this release includes support for Istio as well as the admission controller. So we will have some content coming out later today around that. And then just a reminder to join us at Kong Summit. We are going to be having a lot of really great content around Kong, as well as some free workshops on Kuma as well. So there is a code here if you're interested in joining us. It's happening in San Francisco, October 2nd and 3rd. So this will get you a $50 ticket to join us. So with that, I'm going to hand it over to Marco to talk about Kuma.
Sounds good. Thanks, Caitlin. And thanks everybody for being here. My name is Marco. I'm the CTO of Kong. And I'm here with some other folks from the Kuma team, including Drew, Jacob, and Yaroslav, among the others. I want to go over with you with the getting started. So for anybody who's new to Kuma, how do I run Kuma? How do I start the product? And how do I get really up and running with some basic policies like mutual TLS? So let me share my screen real quick. And I think whoever is sharing now needs to get it. There we go. Okay, perfect. So when we built Kuma with one important assumption. This must be a product that does not just run on modern or containerized environments, but can also run on other environments. This is very important for a couple of reasons. Number one, not everybody wants to use containers and Kubernetes. Number two, some organizations are planning to move to containers and Kubernetes, but for some reason, until now, service mesh and the implementation of service mesh was contingent to a successful rollout of containerized applications. If we look at what's available today, we're looking that in order to implement service mesh in, let's say, Kubernetes, well, first of all, we have to move to Kubernetes. We have to containerize our applications. And then once that is in place, only then we can start using service mesh. That really makes service mesh the last step of modernization, as opposed to really be the first step to modernization. We don't want service mesh to be the last thing we implement. We want that to be in place as an enabler to that Kubernetes and container transition. So when we built Kuma with that in mind, as a platform, a system that must be easy to use, first and foremost, but also needs to be able to run everywhere. So that if we do want to move to Kubernetes, we can use Kuma today on virtual machines as a first step to that transition. If we never plan to move to Kubernetes, fine, we can implement a service mesh across pretty much every other platform. And if we are already using Kubernetes and containers, well, guess what? Kuma runs natively there, so we can easily use CRDs to implement a service mesh. So this is really one of the principles behind Kuma. Besides obviously being open source, besides obviously being a product that wants to be, we want to expand with what we call policies. So once we install Kuma, the control plane, once we start our data planes, then we can implement and apply those policies on top of our systems. And today, this is the first version of Kuma. We're going to be, we provide policies for mutual TLS, for traffic permissions and so on. But we want to keep extending the number of policies that we provide in order to be able to tackle better and bigger use cases. For example, routing. So this is something that we're working on right now, and it's going to be available very soon. So it's a 0.1, right? We want to make sure that we are running on a good foundation, and this is going to be the foundation we're going to be using for the years to come. So we're going to be not only extending and improving the Kuma team over time, but we're also going to be, of course, creating more features and supporting more use cases for pretty much any service mesh that runs on virtual machines, bare metal, or containers and Kubernetes. Now, it's very important, though, to make sure that you guys are all involved into this project. This is a community project, and we are all going to be working together to implement these features and to chat and discuss proposed implementations when it comes to the project itself. It's very important that we can hear your voice, and you can do that by either asking questions to the community calls, which we're going to be having on a regular cadence, or by opening up GitHub issues, or by chatting with us and with the rest of the community on top of Slack. So this is not, I'm looking forward to have contributions from you all. I don't want this to be just a project that we at Kong create. It really wants to be open, and it wants to enable and encourage contributions from pretty much other people and all over the place. So if you have any questions at any point in this video, in this presentation, in this chat, really, this is a two-way exchange. Then write it down, and then after my demo, we can jump on a call, on a conversation, and discuss those features. For example, one of the things that I would like to learn from you is, what are you trying to do? What would you like to see next? And what have you been doing today with Kuma that you would like to see improved, right? And so we're gonna take those feedback at heart in order to improve the product. All right, so for those of you who do not know or have not started Kuma, if you go to the installation page, we can see lots of different versions that we can apply. Kubernetes is, of course, powered by Docker. You notice here there is no Docker installation. It's coming up very soon. So you can use the Docker containers, the vanilla Docker containers, to start Kuma. But for example, let me try with macOS, because I'm running on macOS right now. So downloading and running Kuma, it's very simple. Kuma, by the way, it's built on top of an Envoy data plane. So what we do when running Kuma is downloading the product, and then this bundle for each version of Kuma will include a few different binaries, including the Envoy binary, which is going to be used by the Kuma DP binary in order to provision the actual data plane, and the bootstrap configuration for Envoy itself. So let me go ahead. I'm just gonna execute these steps. And if the demo gods are gonna be good with me this morning, this will work. So, there I'm downloading the latest version. By the way, we're going to be making a new version very soon for Kuma. There we go. So as you can see, I am extracting the project, and we see that we have two main folders. One is the bin folder, one is the conf folder. The bin folder includes all the binaries we're going to be using, and the configuration folder includes, for now, only one configuration file, which is the Kuma control plane configuration file. Now, when we start the control plane, we can start the control plane in a few different modes. We can store all of the information for the control plane in memory, so there is no dependency required, or we can store the configuration on a Postgres database. On Kubernetes, we are going to be storing all the configuration on the underlying Kubernetes API server. So we're running Kuma on Kubernetes. There is nothing else we need to run but Kuma itself. When running Kuma outside of Kubernetes, so for example, on my Mac machine, we need to be storing the information somewhere, because we cannot leverage the underlying etcd system that Kubernetes embeds already within itself. So when we start Kuma control plane, we can obviously start the defaults, which will load an in-memory control plane, or we can start an instance of the control plane that runs and stores the information on top of Postgres. If we look at the configuration here, we have different properties that we can use to determine what is the Postgres database we want to use, assuming that the type that we're selecting here is equals Postgres. I'm not going to do that now. We're going to be using type memory, which is the default. But if you want to use Postgres, this is how you would do it. So let's go ahead and start the control plane. You can just follow the instructions here. So I'm going to be running run, and this will start the control plane. The control plane starts and opens up a few services, including the API server, the Bootstrap server, the diagnostic server, the XDS gRPC server, and the SDS gRPC server as well. The way this works is simple. Kuma implements the XDS API of Envoy, which means that when a data plane will start, it will connect to the Kuma control plane and be a consumer to these XDS servers. Therefore, we can configure the data planes at runtime via a streaming gRPC communication every time a new data plane starts. The API server is a RESTful API server. So for example, I can consume this server on my computer, and it will provide, it's a simple RESTful API that it's always available on both Kubernetes and other environments, and that we can use to visualize and retrieve information for our cluster. On Kubernetes, this API will only be read-only. We can only retrieve information because we want on Kubernetes to apply CRDs to change the state of Kuma. We don't want to change the state by using the API directly. But on other environments other than Kubernetes, we can use the API to change the state. In fact, Kuma ships with a binary called Kuma cattle, which you can run on pretty much any environment. And this Kuma cattle binary, under the hood, what it really does is it's consuming the underlying API server to retrieve the information. So when you're using Kuma cattle to interact with the Kuma cluster, this under the hood makes HTTP requests to the API server, server RESTful API that I just visualized here. So for example, we can do things like /meshes to retrieve the meshes that are available, and this will return the default mesh. Kuma starts by default with one mesh that's always there. We can create more meshes. We can even, if you want, remove the default mesh. And this is the default one that's going to be available as soon as we start a new Kuma cluster. So by doing /meshes, we can of course start inspecting the API. This means we can also integrate this with pretty much anything that can make HTTP requests. So Kuma cattle takes advantage of this API to provide the information, but you can integrate this with anything really. As long as you can make an HTTP request, you can retrieve information from Kuma. That's pretty cool. So now that we have the control plane running, we need to start the data planes. But before we start the data planes, we need to be having a service that we can protect. We can make part of the mesh. So the binary here ships with the binaries here ship with a TCP echo server that allows to start a simple demo service of Kuma, and we can do that by specifying a port field like 9000. This will accept simple requests and echo back the request we're making on the server side. And so, for example, if we use curl and we make a GET request to localhost 9000, we see how the server will log that we've received a new HTTP connection. And here on the client side, it will echo back the request we're making. So this is a simple echoing server. We can also use netcat. So for example, we can use netcat to connect to port 9000. And this will start a TCP connection, a raw TCP connection. So if, for example, we write hello, we see that it echoes back what we're writing, as well as the text is as being a TCP connection, a raw TCP connection as opposed to HTTP. So it's a simple echo server that we can use for this demo today. Moving forward, I'm looking forward to create our own demo application that's a little bit more advanced and nicer to use than the TCP echo. You know how we're going to be using Kuma in the context of a real application that it's going to be having dependencies, is going to be having different components talking to each other. What I would like to do is providing that sample app. It can be, for example, a simple marketplace application. So imagine a super stripped down version of Amazon.com, right? This application will use different services to retrieve the items descriptions, to make a search, and it will also leverage different data stores to storing that information. So I want to provide a demo application that includes these different components in a UI, of course, so that we can use that moving forward for every example that we want to apply on top of Kuma, and that you can also use internally or in your organization to demo what Kuma does and the feature it provides. This is something that's coming, and once it comes, it will most likely take over this Kuma TCP echo sample application. Okay, so I am running on localhost, the control plane, and a simple application running on port 9000. So what I want to do here now as the next step is really starting the data plane. There are different ways to start a data plane, depending if you run on Kubernetes or not. If we do not run on Kubernetes, we have to use Kuma-catl. And by the way, let's use Kuma-catl now to inspect, because we have a control plane running. We can use Kuma-catl. So first of all, Kuma-catl, if you don't specify the command, it will return a nice help dialog that tells you exactly all the commands that are available. And in particular, I want to make sure that if I config the control planes and then I visualize them, okay, so list, Kuma-catl config control planes list. This will list the control planes that are available from this Kuma-catl environment. This configuration, it's initialized by default with a localhost control plane, but we can add more control planes. So for example, if we do run a Kuma control plane cluster somewhere else, it can be in the cloud or can be on another machine, we can add that control plane to this list, and then we can start using Kuma-catl with that remote control plane. In fact, I can use Kuma-catl to add as many control planes as I want, and I can switch between them by using the switch command, which is described here. So I can switch the active control plane from one to another. So by default, we consume the local control plane, which by the way, is the API I've just demonstrated. So if by default I type get, for example, meshes, I can see what are the meshes that are available on the system. And we're going to be seeing that there is one mesh with mutual TLS off, the access logs are off, called default. If I retrieve the data planes, there are no data planes. So we have a service. Let's start the data plane for this service. To start a data plane, we need to, first of all, do a couple of things. Number one, we need to tell Kuma, the control plane, that there is going to be a new data plane with the following properties that it's going to be connecting to the system. In this case, in this example, we have a new data plane that's going to belong to the default mesh, that's going to be having a name DP Echo 1, that defines the following networking configuration. Now, the networking configuration is very important because it determines how the data plane reacts when a new incoming request comes in or a new outgoing request is being made through the data plane. So in this example, the data plane is telling the control plane, hey, I'm going to be starting on port 10,000. So this is the external port. And every request on port 10,000 will be proxied to port 9,000 on the same host. Why 9,000? Because that's the same port as our service. So this is the external port that determines what port we have to consume in order to make a request to the service via the data plane. And port 9000 determines where that request will go in the same host after it reaches the data plane. We can apply a series of tags. One tag is mandatory, and that's the service tag. Now, you will notice that in version 0.1 for Kuma, you have to be very careful when you write this configuration because we're getting better with the validation. So if this is not formatted the right way, it might throw some weird errors. So we're going to be improving that, of course, as the product gets better. But just pay attention to make sure that whatever you're writing here matches the data plane specification documentation that's documented on the docs. So here you can find a full spec of how to create this document. On Kubernetes, you don't have to do any of this. On Kubernetes, the data plane will be automatically injected without you having to specify any data plane configuration whatsoever. So it's all automatic on Kubernetes. This only applies if you're not using Kubernetes. So we create a new data plane type, and then we apply that configuration with Kuma cattle. I can just execute these commands, and they should be working. Oh. Perfect. So now I've added the data plane. If I get the data planes, I'm going to be seeing that there is one data plane in the default mesh and belongs to the following service, and it's called DP Echo 1. We're going to be having one instance of the data plane for every instance of our service. So there is another command that's very handy called inspect. If we inspect the data planes, we can visualize the insights for every data plane that has been connected to our control plane. And so we are noticing that the DP Echo 1 data plane, it's being configured on the control plane, but the status is offline. This is because we never started the data plane yet by using Kuma DP. We just configured it. So let's go ahead and start the data plane. Starting the data plane is as easy as running the Kuma DP executables, which under the hood will start Envoy. So if we start this command, we expect a few properties like where is the control plane going to be located at. So we need to specify this so that the data plane can retrieve the bootstrap configuration from the control plane, as well as to what mesh it belongs to and what's the name of the data plane we're trying to start. So this information have to match whatever we have defined in the data plane type up here. So if I do this, let me start a new window because here it's getting a little bit busier. Actually, I'm going to start a new window for Kuma cattle later, so I can just gonna use this. So, right, so if I run this command, this will start our data plane. If I go on Kuma cattle again, I can, of course, retrieve the meshes. I can also retrieve the data planes like I did before. But most importantly, I can inspect those data planes and see that now the data plane I just started is online, which means that we have successfully added a new data plane, and that data plane is successfully communicating with the control plane. We can see a few diagnostic information here, like when was the last time it connected, when was the last time it was updated, and so on. Now, once the data planes are running and they are running and talking to the control plane, we can start applying policies on the control plane in order to change the behavior of this data plane. So we never have to configure the data plane directly. We'll go to the control plane for doing pretty much everything we want to do. So for example, we can apply a mutual TLS policy. Now, if I try to consume this data plane on port 9000, it will work because this will, let me see. Okay, so this will consume the service directly, but we don't want to do that. We want to go through the data plane first on port 10,000. If we do that, we're going to be seeing the same answer. So this is a request made directly to the service, which we never want to do in production. And this is a request made through the data plane. The data plane on port 10,000 will receive the request, and then it will proxy it on the same host on port 9,000, like we have configured here. Now, this is standard HTTP. One of the things we want to do is protect and secure this communication. So for example, if you go on the mutual TLS configuration, we can enable automatic encryption on top of this mesh by applying the mutual TLS, the MTLS, enabling MTLS on top of our default mesh. We do support today only one certificate authority, and that's the one that's built in on top of the control plane. Moving forward, we're also going to be enabling this CA to be external to Kuma. So you can integrate it with a third-party CA authority if you want. So to apply mutual TLS via policy, we must create the policy. So we can update our default mesh by enabling mutual TLS with the default built-in configuration. So if I do this, we apply mutual TLS. If I go on Kuma Carol again, and I try to retrieve the meshes again, we see that now the mutual TLS is on. This means that if I make a request again on port 10,000, this request will now fail because it must happen over HTTPS. In fact, it's not going to be working. We need to be, let me see, we need to be making these requests. If I'm not wrong, this will work. We need to be making these requests on top of HTTPS in order to make it work. If we consume, in fact, of course, this is a self-signed certificate, so curl does not recognize the client certificate that we have set in order to consume the service. We need to be able to provision a mutual TLS certificate in order to be part of this mesh and therefore making a request to the service. But the service itself didn't have to implement any change whatsoever. So if we keep making a request on 9,000, bypassing the data plane whatsoever, this will keep working. So in one click, we have enabled mutual TLS on top of the mesh, and now the service is being protected and it will not accept any connection by anything outside of the mesh that doesn't provide the right client certificate. In fact, my curl requests are now failing. I see there are some questions on the chat. Let me pull up the chat real quick. Oh, I see. It's about Kong Summit. Are there any questions so far on how this works? Or are there any requests on improvements on how this works?
If we don't have any questions from the folks on the call, I know we have a few that folks asked on the Slack channel. We have a Slack channel called at chat.kuma.io that you can join. But if you can address a few of those, Marco, that'd be great. Because I know those folks said that they couldn't join.
Let me see.
I believe the first one by Kwan's that I addressed yesterday is how would Kuma integrate monitoring and alarming or alerting in the future?
I'm sorry, let me pull up that question real quick. Which one is it?
It's by Kwan's that I sent yesterday. He asked about how to integrate monitoring and alerting for Kuma.
Would that be for tracing or for, you mean for the actual control plane itself or for the data plane workloads?
I think for data plane workload is what he was getting at.
I see. So, well, the data plane really starts up a few, it's a networking component, right? It's number one, a process. So if we look at what we have running, we have a new Kuma DP process running, which under the hood we'll start an Envoy process, right? So this is the Bootstrap configuration that been automatically fetched by the Kuma DP process, and we can see it here. So we want to make sure that effectively Kuma DP always is up and running. And if it's not, that means the data plane has crashed, right? So we can do that by either checking the process, or we can do that by making requests to the actual service to visualize and make sure that the ports we have open are indeed reachable. Starting from next week, I want to be providing a live demo application. So we're working on a few mockups here. So imagine a simple marketplace store that would effectively start a few components. And then we're going to be using this for the official demos so that we can do something that's a little bit more meaningful and less low level than having this TCP ecosystem running and then manual core requests to the product. I think it would be very beneficial for the community and for the project itself if the demo was a little bit more representative, so that it would be easy to understand how policies are impacting and affecting different components of a microservice-based application.
Check.
I can hear somebody.
Hey, Marco, in your example there, so is port 9000 is what the underlying service is running on, and you know, you're kind of hiding that behind the mesh here, and you know, when a client calls, they're going to call on port 10,000. What's stopping, you know, someone calling that service directly on port 9000? Or is that the intent, huh?
That is a very good question. It is important that when we set up the, you know, when we start a new virtual machine, we make the request accessible only via the ports that we are exposing via the data plane, right? So it is important that the ports of our services are only going to be accessible from the data plane that's running on the same machine, but not from anywhere else. So for example, if you're running on EC2, we can set up a security group such as the only external ports that are available are the ones that the data plane exposes.
So where are you locking down that port, that service, Marco, with to 9000, only the data plane? Is that in your config or something, or do I have to write any code on my client to do anything?
We need to prevent that. We need to exclude that from being exposed in the network in the first place. You know, if somebody wants to buy everything that the service mesh provides, it can be executed, it can be provided just because the data plane is executing that function. The mutual TLS, it's being executed by the data plane. The traffic permissions are being executed by the data plane. So everybody must go through the data plane in order to be able to enforce that. If they're bypassing the data plane, then the whole product does not know that the service is being consumed even in the first place. So it is important that we can lock that down from a networking standpoint. Now, I believe that maybe there is a way, and I'm asking a question to my team, maybe there is a way with transparent proxying to catch every incoming request and automatically block it if it's not being consumed, if the incoming request does not consume the data plane. But I'm not sure if that would even be possible. Yaroslav or Jacob, do you know if that's even possible?
Yes.
To provide a transparent IP tables rule that blocks every external request that's not on the data plane?
Yeah, I can try to answer this question. So first of all, back to your original question, how would you prevent from somebody making direct request to application? if you look into our example, you will notice that we start both application and data plane, and we bind the networking address to localhost, so 127.0.0.1. So, and as long as your application listens on this IP address, it's not accessible from outside of this machine. So the first solution for you, if you run, for example, outside of Kubernetes, you just run your application, you bind your listeners always to localhost. This way it's inaccessible from outside of this machine. But when you define listeners for your data plane, you use publicly accessible address. So, and in this way, traffic will always go through data plane and will never will go through original application directly. So this is the first, the most usable approach in any universal environment, traditional universal environment. On platforms like Kubernetes and also in data center, if you want to, you can also make use of IP table rules. So essentially, IP table rule allows you to apply redirections to both incoming and outgoing traffic. So you can define rules that every incoming traffic into your machine should be redirected into data plane, and then data plane will forward this traffic to just original application. So in this case, you can also, again, achieve this goal that everything goes through data plane first. So you have two options. First option, you just bind to application to localhost. It's easier. The second option with IP table redirection, well, it's also easy on platforms like Kubernetes, or if you have full control over your data center. So yeah,
Well, that's brilliant, guys. Yeah, thanks a lot for that. Yeah, I was thinking maybe the product might do that, but on top of the product, we have to still kind of lock that underlying service down through.
No.
Mm-hmm.
It's just a matter of configuration.
Config though via IP tables or network security groups or something or other. But even on local hosting, of course, I could still call that service on the box itself from another app on the box. But I think it's good though. You're locking out all external access from to anyone external to that box can't get to the service. They can't even hit it.
Yes, so if you're thinking about security inside the box, so that not every application can call it inside the box, this is where Linux networking groups come in,
Mm-hmm.
network namespace. So if you, for example, run this inside, both data plane and origin application inside one network namespace, then it will also make them inaccessible from another Linux network namespace. So it's mostly.
Mm-hmm.
So it's mostly a matter of configuration. So you have multiple options how to achieve this. Yeah.
That's brilliant. Thank you, guys.
Mm-hmm. Back to you.
Is there any other question?
If there's nothing else, oh, there's one in the chat, Marco. Oh, just a comparison. What's the difference between this and Istio? I mean, this is a question we've seen pop up multiple times in our Slack channel too. If you could kind of address the group here and for the recording.
Yeah, so Kuma has been built with a few different foundational principles in mind, as opposed to systems like Istio. Istio is a system that works, that has been built on top of Kubernetes, that has been built by leveraging intensively the Kubernetes primitives. That makes Istio very hard to be deployed outside of Kubernetes. Now, Kubernetes, when we look at service mesh, I'm a big believer that service mesh, the bigger it is, the most valuable it is within the organization. So a service mesh, in order to be the biggest and the most valuable, has to be running on systems other than Kubernetes as well, because enterprise organizations today are not running all their workloads on Kubernetes. They're running most of those workloads on virtual machines already. So how can we, number one, enable those workloads to transition to Kubernetes, and how can we support them if they're never going to be transitioned ever from Kubernetes? Kuma has been built with platform agnosticity in mind, which means that you can start Kuma on Kubernetes or outside of Kubernetes very easily. You're not limited by using Kubernetes only. That is a big difference. Every team in the organization can use Kuma, the ones that are using Kubernetes and the ones that are not. The second thing is that systems like Istio are very complex, very hard to use, hard to deploy. There's lots of moving parts that goes into running the Istio service. With Kuma, we wanted to get rid of all of that. Kuma is a Golang executable that on Kubernetes, by the way, does not require any dependency. So you can deploy this thing in one command. We've not watched the Kubernetes installation. So basically, if you go on Kubernetes, you can install Kuma in one command, and this command will install only one service, and that is the Kuma CP service, as well as the sidecar injector service. And that's pretty much it. The only thing you need to scale is adding or removing replicas of this one service in order to run. There is no Mixer, Pilot, Citadel, and none of that. It's very simple, and it's built for simplicity and ease of use. So lower operational cost and simplicity and ease of use. Third thing, we wanted to support multiple teams at the same time by supporting multi-tenancy at the same time. We heard from our users that one of the biggest pain with existing meshes is that for every new team that wants their own mesh, they need to start a new cluster of their own mesh. So with Kuma, we implement multi-tenancy since day one, and we allow on the same control plane to support as many service meshes as you want, which means that running one mesh is as hard as running 1 million meshes with Kuma. There is no difference. It's multi-tenant since day one. And last but not least, we're going to be implementing an API which would allow meshes that are running on different platforms to be communicating with each other, which means that you can have a mesh that can span across multiple Kubernetes clusters, as well as Kubernetes and virtual machines with Kuma, with one system, without having to introduce any new dependency or any abstraction layer above that. So to recap, platform agnosticity, so that every team in the organization can use it. Simplicity, we want this to make it simple to deploy, simple to install, simple to scale, and simple to use. This is at 0.1, so we're gonna take it from here and make Kuma the simplest service mesh in the world. That's the whole point of Kuma. The same simplicity that that Kong has provided in the API management space with Kong Gateway, that same simplicity we want to replicate in the service mesh world. Service mesh does not have to be complicated. We wanted to simplify it. And then third, we want to be able to really support an extensible framework when it comes to creating those policies. So up until now, we're going to be creating the first initial policies, but we want to create an SDK that would allow anybody to create policies on top of Kuma the same way you can go ahead and create a plugin on top of Kong. So we want this to be open, to be running everywhere, to be simple to use. And that's really goes against some of the principles that existing service meshes are implementing today. They are either Kubernetes only, they are very hard to use, or they have lots of moving parts, and they don't make service mesh an easy pattern to be adopted within the organization, which is what Kuma really wants to fix.
Awesome. Thank you so much, Marco, for that. I think you also addressed another question we had in our Slack channel just today about if you want to span the mesh across multiple Kubernetes clusters. Seems like that's a feature that's coming up soon.
So there are more questions. When do you think Kuma might be production ready? So this is the first version of Kuma 0.1, right? We are building Kuma, paying lots of attention on the stability of the features and the stability of the product itself. But of course, it's at 0.1, right? So it can only get better from here. We are starting from the 0.2 we're going to be exploring and running Kuma in production on our own services as well. So I would start experimenting with Kuma today, but I would probably wait until 0.2, 0.3 before pushing it into production. But there is no problem into running it in a staging environment, and the mutual TLS has been tested a lot. It works well. The features that we provide are very well tested. So, I mean, unless you experiment any specific problem, you experience any specific problem, you can give it a try. it is important to understand that Kuma does not reinvent the underlying networking functions that we're using to manage and process those requests. We're using Envoy, which means that for Kuma, it's going to be a much easier and how can I say, a much more solid journey into production, just because we're not reinventing the hard stuff. The hard stuff are being, the networking components are being provided by Envoy, which has been running in production for a while. So we're leveraging that stability, we're leveraging that solidity and that production experience of Envoy itself to build Kuma. So give it a try. And we don't think there's going to be problems, but if there are, please open up an issue. We're going to be very responsive. It's at 0.1, so I would start with staging first and take it from there. Another question, is there any performance configuration issue or conflicts? If multiple teams have their own meshes and wants to manage, we are going to be implementing that. So basically, the question is, can you implement a role-based access control so that basically you can restrict, if there are multiple meshes, you can restrict what the teams can do or cannot do on top of those meshes. So we're going to be implementing a role-based access control that's going to be working on both Kubernetes and virtual machine deployments. And for Kubernetes, we're going to be exploring leveraging the Kubernetes RBAC in order to be implementing some of these features. We want to follow the Kubernetes best practices when it comes to Kubernetes. So we you know, it's going to happen, but it's not available today. I'm very excited about Kuma. I'm very excited about the work you know, the community has been doing. So the next community call will be even more exciting. You know, this is all a learning experience for us as well. We're going to be accepting community call contributions for the next topics. So if you build or do anything very that you want to showcase with Kuma and you want to present that to the broader community, please let us know on the Slack chat and we can make it happen. This is not really, this is our project. It's not our project in the community. We really expect everybody to be a part of it. With that said, I'm looking forward to see you all and meet you all at the next community call. We're going to be working on a few new features. One of them being a new traffic logging policy, which would allow to showcase an easier way to integrate Kuma with products like the ELK stack, Kibana or Splunk, for example, as well as I'm looking forward to be creating a nice demo application. So the next time there's going to be less command line and more point and click for an easier explanation of what Kuma does. Oh, that's a very great point. If the demo app can be hybrid, I mean, we're going to take that into consideration, but that's a very great use case for something like Kuma. Absolutely. That's a very good point.
Awesome. If that's all the questions that we have, if you guys have any follow-up questions, you can always ask on our Slack channel, or if you have an issue with Kuma and you know something you can't work through, you can always open up an issue on our GitHub. And to wrap things up, Caitlin, do you want to take over?
Yeah, so I just wanted to drop the link to the Slack channel in there if you are interested in signing up and joining us on there. Our next community call is scheduled for October, so we will see you all then. Thank you all for joining today.
Oh, and one quick shout out to Lars, our first community PR. So yeah, he actually put in multiple PRs now, so I just want to give him a shout out because he might watch it. So
awesome. Thanks, Lars.
folks.
Thank you guys. See you at the next one.